Welcome to the first official episode of Safety Factor. My name is Ben Hanks, and I'll be sitting in the cab here and guiding this thing along. This is a podcast where we're going to be talking a lot about how you can stay safe while you're doing your job, or how you can keep your employees safe while they do their jobs. In this first episode, we're talking about overhead cranes. Specifically, we are talking about creating safer work zones with smart, non-contact measurement solutions. I'm here with Steve Lubeck, President of LaserView Technologies, Mark Shubel, Director of Business and Training Development for Crane Service from Mazzella, and Kenny Wright, VP of Process Cranes and Modernizations from Mazzella as well. Guys, thanks for being here to help kick this thing off. Steven, could you quickly tell us, for those who don't know, what are smart non-contact measurement solutions? And can you tell us a bit about what LaserView Technologies does in the field?
Yeah, sure. Thanks. So basically, non-contact solutions are any sort of solutions for cranes that do not deal with contact sensors, sensors such as limit switches and paddles and things like that. So the smarter non-contact solutions use sensors such as laser sensors and other non-contact sensors with smart controls to be able to enhance and modernize what a crane does and make it safer than just the basic operation it was initially intended for. So LaserView in general does work on overhead cranes for collision detection, no-fly zoning, and hoist safety. However, we also, before dealing with cranes, really started with automation in general, providing the automation industry with non-contact lasers and other kinds of sensors such as that. And we eventually got into the crane market several years ago and have made a presence in the overhead crane market.
All right, thanks, Stephen. Mark and Kenny, can you tell us a bit about your background and your experience in the field?
Sure. I'm Mark Shubel. I'm the Director of Business Development and Technical Training at the Mazzella companies, and I've been involved with skilled trades, engineering, and service management for the last 47 years, and specifically overhead cranes in general for the last 35 years. And I've been with Mazzella companies for about the last 10 years. My background's mechanical and structural, although I have a smattering of all the other different skilled trades training also.
So I've been in the overhead crane business for almost 30 years now. My background is electrical electronics. I have a degree in both. And I got into the crane world because of Mr. Mark Shubel here. And it wasn't that I was actually out seeking to become a crane guy, but I had the experience and met up with Mark, and here we are today. So it's all his fault. So yeah, my experience with Mazzella's and with our own company is crane service. Moved over to the engineered product side of the business to run the engineered product side with modernizations, process equipment, and engineered cranes. And we've now been running this division for about 4 years.
So we've got a lot of years here collectively to fall back on. So why are we talking about creating safer work zones now? Was this a concern 10 to 20 years ago?
This has been an issue for the overhead crane business, I'm assuming, since cranes came into use, literally 1,000 years ago. And just in our lifetime, it's gone through a lot of different progressions to come up with safe work zones. And what Steve's working on now is a current, leading technology. But basically, it started out with simple things like graphics mounted to overhead crane girders and the runway systems to warn the operators that they were in an area where the hoist trolley would or could impact a piece of equipment underneath it, that kind of thing. It moved into the next level, which was electromechanical limit switches and proximity switches used in conjunction with relay logic controllers that were mounted on the crane girders to tell the crane basically where it was, or the hoist trolley where it was on the crane itself, so that it can either slow down or stop moving in certain areas. That kind of progressed into motor encoders and relay logic to determine precise positioning of the crane in the hoist trolley through the encoders. That kind of moved into photoelectric sensors and photo eyes with large targets, in essence, which basically they emitted the light and reflected off of the target, and it was reflected back to the emitter, if you will, to determine whether or not it was within range. Now we've gotten to the point where we're at now, which is with the laser-driven non-contact measurement solutions that Steve's companies offers. A lot of what we do in the crane and hoist business, not just from a manufacturing standpoint, but from a service standpoint, is we act as not only innovators to bring new stuff into the market, but also integrators. So Steve's point earlier about this coming from the automation background, and then, himself and a lot of other companies like us have basically worked to try to integrate those technologies into the overhead crane business as they become more affordable and user-friendly, if you will.
Is there more emphasis on safety now than there was in the past?
Absolutely. There's a tremendous amount of emphasis. Now, as you guys probably know, OSHA was started up in the early 1970s, and it was basically just to monitor worker safety in certain industries, and it's become very, widespread now to the point that safety is a major factor in a lot of what the plants, our end users do, and certainly is a big driving part of what we do in our business at overhead cranes and overhead crane service. So yes, safety has become very important in our industry.
The thing that I hear a lot when I go into production plants, especially like stamping plants, for example, is that the level of employees has changed to the point that there's not as much care in the every movement that they make, and that's why no-fly zones have become somewhat of a more popular request now, because people are more distracted. There's more distractions with cell phones and all that. And now you have other things that are distracting you, and you're not paying attention to the loads on a crane as much. And no-fly zones have become more popular. We have customers who've had buildings, that offices under the crane runway, and they've been there for 20 years. And all of a sudden, now someone runs into it and runs right through a building. But the building's been there 20 years, and the crane runway's been there 20 years. So people were careful, and I guess people have always had accidents. But it seems like this is more on people's minds as this happens more and more now.
And it's one more thing to that is the technology has grown, so just fast, I would say, to where you have devices now that you can put on at I'd say an economical price that people can afford. You think about all the devices that are on a car or a truck these days. When you go buy your truck, you got sensors all the way around it that keep you from backing into somebody, keeps you from getting too close to somebody that you're following on the roadway. So our generation that we grew up in, we were always doing things the manual way. These days, it seems like the younger generations, they invite that kind of technology to be on everything they use. Every machine, every crane, every thing that they use in the field, they expect it to be on there just like it is on their car or their vehicle. So the technological advances have put us to where systems that Steve can offer are wanted and invited to be in the field anymore. 20 years ago, they would have laughed you out of there because it slows me down.
So let's talk about some of the technical advantages. Like, what is the technology now? Like, what are some things that are out there that people might not know about, or things that are being developed, things that are exciting to look forward to?
So one of the things is that, laser sensors, for example, before were limited to range, or maybe photoelectronics, and they were less distance. Well, now the lasers that we use in the cranes can go up to a 1,600-foot runway. Recently did a commissioning on a 1,000-foot runway, measures no problem to a target. So when you can now go to a long runway, whether it's a short run or a long run, but you can do a long runway now, you always know where a crane is in the runway. You never have to guess, is it working? Is it not working? Am I getting too close? It's an absolute thing. So what's changed is now that we have sensors that are more reliable, longer range, more stable, more accurate, we can continuously monitor where that crane is in space. And not just where the overhead crane is, but where the trolley is, where the hoist is. We typically put 2 lasers on a crane. One looks at the trolley position, the hoist position. The other looks at the bridge position. So now that we know where everything is in space, we always monitor it. There's never a time that it's unknown where your crane is. And because of that, we can reliably not just stop a collision with another machine or a building, but we can also make sure we slow it in time and then stop it. The other piece of the puzzle is there's more computing power built into newer PLC controls. So we're using, on most part, PLC controls in our systems, not PC controls. And there's a debate, which is the best in this day and age in 2022. However, PLC controls will run and run and run, and they don't do blue screens of death and all the things that you have on PCs. So we can run very fast, powerful programs running through PLC controls, monitor all the sensors, monitor all the zones at once, know where the position is, and do outputs to the variable frequency drive of a crane, and or wireless outputs to other pieces of machinery, which we haven't even talked about yet, that may be in that runway, in that crane bay. One other thing, Ben, and is that in addition to the laser technology and the processing technology, wireless technology for wireless discrete I/O has gotten a lot better also. So now, not only do we have the ability to slow and stop a crane, but we also have the ability to warn other machines, other devices, other cranes even of potential collisions or accidents. So the wireless technology has improved a lot as well. On top of that, we also have the ability now with Wi-Fi to be able to set the limits on cranes from the ground. So now we've even taken advances from when we've started Crane Century to the point of you have to do all your settings up on the crane. So now you can do it on your phone or your pad or a computer on the ground without ever having to get back on the lift to make that change on the program.
So that's a whole other aspect of safety there, because now you're not having to get up on the air. You're not having to worry about fall protection gear. You're not having to worry about falling. So that's an extra form of safety right there.
It also adds into the efficiency of the maintenance team that's, taking care of that piece of machinery. Getting a man lift over to get up on the crane takes time, so that takes time away from production. So it does improve the efficiency, and the production guys love that part.
It also opens up the ability now to do remote monitoring. So now that we have that access, and now we have the access through Ethernet industrial protocols, essentially, we quite often for some larger facilities do remote access. So we can literally remote into a crane from our office and watch the crane move, loads lift, see what's going on. And I can tell you if you have a bad sensor. I can tell you, I can help configure something. We can help make settings. We can help figure out why a zone keeps shutting the crane down because you're too close, or you have a slow zone that's not large enough and you have not have it set properly and you're flying through the zone because your crane's too fast. So there's some things that we can do remotely that really cut down on maintenance costs overall, because now you do not have to pay a field service just to come out for a very simple problem.
So let's talk about some of the hurdles that you run into in getting people to adapt to this new technology, use this new technology. So can we talk a little bit about the limit switch mentality? So what is the limit switch mentality?
To me, the limit switch mentality is, well, we can do it with limit switches, and I can do it less with limit switches. Well, there's some truth to that, but the truth only goes so far. The truth is that, yes, limit switches themselves are less costly devices. However, you must physically mount the limit switch, and every time it's not right, you got to get on the lift and you got to move that limit switch over a foot. Limit switches are mechanical. Overhead cranes get there's dirt and there's debris on the rail, and there's little metal shavings and there's just, they're not maintained. Those limit switches don't get maintained. So what happens is that limit switch may flip over. And I often call them windmill switches. They'll flip over and they may never flip back, and they can get stuck in position. So windmill switches are a maintenance issue because now they're mechanical switches that either get damaged, get dirty, don't flip back, and you have to move and to reset them. But a limit switch is not the end of the story. You can have a limit switch, but you still need the logic. So if you have one no-fly zone and you have a limit switch, that's one thing. If you have 2 or 3 or 4 or 5 or up to 8 no-fly zones with limit switches, you have to have limit switches on your trolley, limit switches on the bridge. You have to have a limit switch for slow down, for stop, in each direction. It's a lot of limit switches, a lot of wiring, and still logic you have to do. The ability to take one laser from one direction and one laser for the other direction and have infinite control of where you slow and stop is so much smoother and easier to diagnose in the long run. In terms of the limit switch mentality, the people just think they can do it with limit switches because they're familiar with on, off, and it's simple to understand. Once they see this, the reaction is, oh, wow, that's cool. We don't need limit switches anymore. And that's usually what we get from all this.
So, and also, Steve, one thing to add on the maintenance nightmare with the limit switches is that they very seldom stop or slow you down in the same spot every time. A mechanical switch is not accurate at all. And I don't know that you could even put a percent on it as to, what that accuracy or lack of accuracy is, but they do not stop you and then slow you down in the same spot every time. And what he was getting at with, if you had all these different zones and you had to have all these different limit switches, I mean, the piece of machinery, no matter what it is going to look like an alien, going down the runway or on the pad that it rides on. And then the sequencing, it would be a nightmare. Relay logic has always been easy to follow, but when you have all these different limit switches in all these different locations, how do you keep up with that? How do you create a chart that you can say, well, it's switch number 5 over there that's creating a problem for all these other switches? So the limit switch mentality goes back to what I made comment on earlier too, is the older generations were, you're not going to put anything electronic on my piece of equipment because I don't know how to work on it. As the younger generations came along and, they embraced technology, that limit switch mentality, keep it simple, now to the younger generations is keep it simple and put a piece of electronics on there that I can work with. So it's just a different thought process altogether.
Sure. And then to add to that, Kenny, is basically the relays themselves. We talked about the limit switches and failures on them, but to every point that Steve made, if you had 7 different zones you were working with, you'd have to have relays inside of an enclosure, which makes your enclosure larger, and then all of the contact relays inside of them, which are all highly prone to wear and failure also. So the panels get larger, the wiring gets more complex, and there's more opportunity for failure, not just in the switch itself, but in the relays themselves also. So there's a lot more maintenance involved. To answer your question, Ben, that kind of a thing that's maintenance driven. And to Kenny's earlier point, everybody's been reluctant to mount anything new on a crane for a couple of reasons. One, if they're not familiar with it, and 2, if it adds complexity or maintenance to the crane, is it worth it?
So, Stephen, what are some of the hurdles that you're seeing to get people to adapt to this new technology?
I think part of the hurdles is kind of what Mark just mentioned. People are a little leery of putting lasers on the crane. They say, oh, they're going to get dirty. They need cleaning. Well, lasers now, our lasers in particular, can handle a good bit of dirt. But that doesn't preclude that you don't have maintenance, that you clean things eventually. You have to inspect a crane. You put it as part of your as your procedure. Operators kind of feel like if you put no-fly zone system on this, that means you're not trusting me to control this crane. And what they don't realize is that it's also because it helps them. They're still in control of the crane. It helps them give better control of their crane, because now what happens is that they can concentrate on where they're moving their material, as opposed to where am I moving my material, and oops, am I too close? Am I going to hit this object? So they can concentrate on doing their job more efficiently and less worrying about the hazards of what they have to hit. So once you show the operators how seamless it works, that hurdle goes away. But initially, they see it as you're just limiting what I can do, and now I'm not going to do my job. So from the operator standpoint, that's the hurdle. From the maintenance standpoint, they think it's more there, and they don't know what happens, and they say, well, how can I jumper it? How can I override it? And we explain to them that we have procedures in there to override it electronically if there's a problem. The other thing that we do to help with this hurdle is that we have indicators, visual indicators, that show the directions that are enabled and disabled. And you don't get that with old school technologies. So what you see shows your enable. Well, if your crane can't go forward, but my controls say they should be going forward, then you know where to look. You know to look either at the drive or a relay in between the drives, but you at least know that the controls say it's supposed to be going forward, that you have a live laser reading. All that is good. You can start to pinpoint where to start looking. And by telling people these things, they tend to get over the hurdles.
With any particular plant that we go to, you're always going to have, a few operators that no matter what you do, they're not going to like it. They're accustomed to this piece of machinery running a particular way. 90% of the people that oppose everything that we do, Steve, at some point do come on board and say, yeah, I can see what you're getting at. This is going to make my job safer and easier. And it's not really going to hold me back in what I need to do. So those that are hesitant, they usually do come around. There's maybe 1 out of 10 at any place you go to that no matter what you do, they're not going to like it.
And anytime we have change, which all of us know change is new and people are reluctant to change for the most part, but it all comes down to change management also, and how we talk to the customers when we're presenting stuff like this, and when we talk to the operator specifically. And Kenny and Steve do a great job with that to try to explain to them how this is going to be more efficient and safer for them also. So really, when we talk to customers, to Kenny's point, we have to talk to them not only about what we're presenting, but how it affects them and the operators. And we need to and always do get operators involved in these types of things, and then walk them through a training program once we do a retrofit or a modernization. And again, Steve and Kenny do a phenomenal job with that. But it all comes down to, again, change management. People are somewhat reluctant to change. So what you try to do is mitigate as much of that, those objections, if you will, by covering topics that will make it clearer to the individuals that you're talking to. So, for instance, if you're talking to the production people, you talk about the efficiency. If you're talking to the operator, it might be his safety and, making sure he gets home at the end of the day and can handle complex lifts that always made him a little uneasy because he didn't have the control of the crane or position of the crane that he has now. So there's a lot of different ways to present it.
I have found, after we've done installs and commissionings, and if we spend time after the fact working with the operators and asking their questions, it goes a long way, as opposed to just leaving it to the plant management to do that. And once they start asking the people who put it in questions and they talk to them, they tend to accept it more. So that goes along with what Mark was saying.
Thanks, guys, for coming out to Safety Factor. So, Stephen, how can people get a hold of you? How can they find you?
They can always contact us at our info account. It's info@laser-view.com. And anyone can reach out to me directly as well. And I could talk about any application that anyone has. Be more than happy to talk about exactly how it works and ways we can make solutions work, and ways we can make it work with Mazzella as our partner in this business as well.
Thanks, Steve. Check out LaserView Technologies, and you can get a hold of myself, Mark, Kenny, or any of our other experts at MazzellaCompanies.com. don't forget to pop into our Learning Center. We have a ton of information on overhead cranes there. We'll be back monthly with Safety Factor, and this is part 1 of a 3-part series on creating a safer and more efficient work zone with smart, non-contact measurement solutions. Next time we meet with Steve, we're going to talk about how they can improve your efficiency. You can subscribe to wherever you listen to your podcasts, or you can watch it on the Lifting and Rigging channel on YouTube. Thanks for listening, and stay safe out there.